Welcome back. Hey, I really enjoyed those talks about privatized space and all the implications of the space business. It's like we punched a hole into a new dimension. So that thrilled me. And it's kind of cool to see all that innovation happening here in South Australia. What many people, when we talk about innovation centers, technology innovation centers like Silicon Valley, what many people fail to remember is that the origin or the genesis of those innovation hubs is very frequently the defense industry. It's kind of like the secret origin of Silicon Valley is the defense industry. All the spending in World War II to develop radar systems is where we began with Silicon Valley. And in some respects, all of those space companies that we just heard from and their competitors owe a great debt to a company that has been here for many, many years, BAE Systems. Our next speaker is going to tell us a bit about what BAE Systems and the defense industry here in South Australia is doing. This section of our talks today is about technologies that can augment human capabilities, make people better at their jobs, help us get things done better. We have three superb speakers, and our first one is Sharon Wilson. She is the head of industrial strategy for BAE in South Australia. Welcome her to the stage.
Thank you. I'll just adjust for my height. So I have no slides today, which you might be grateful for. However, I can talk for quite a long time without any slides whatsoever, which you might not be grateful for, but I'll try and stick to the time frame. I'd just like to talk a little bit about BAE Systems as a business. I think most people may have heard of us, but maybe not. Our oldest business actually started in 1560 in the Royal Gunpowder Factory in Essex, and we continue today to produce gunpowder in both the UK and in the US. Today we've got around about 85,000 people worldwide. Half of those are in the US, and the rest split between the UK, Australia, and Saudi Arabia. And some of our products are actually very, very innovative products. And if we talk just about Australia, we designed, developed, and produced Norco, which is the most successful defence export from Australia, and is in service with the Canadian and the American navies on every surface vessel, and also obviously in Australia. And that is world-leading technology in both electronic warfare and hovering rocket technology, which basically the rocket seduces missiles incoming into a ship and pretends that it's something else, and thus protects the ship. So really cool technologies that we produce and have produced for many years. BAE Systems has been in Australia for 65 years. We actually started in Woomera at the rocket trials. In previous businesses, the GE, General Electric and the Bristol Aircraft Company, when they were doing trials in Woomera, and we've been here ever since. So maybe I'll talk a little bit about my role in BAE Systems Australia. I'm essentially, as head of industrial strategy, that means I can do anything I like. And I actually wrote my own job description, and nobody knows what I do, they just like it, so I carry on. And essentially what I'm trying to do, I'm the disruptor in the business, okay? So I'm the person that asks the question, why are we doing it like that? Why aren't we doing it like this? I'm actually in business development and strategy, and I interfere with everybody, okay? So that often gets me into trouble, but I'm not bothered about that, as you might have gathered. So if we talk about some of the myths in defence, you see the big dollar signs. Yes, the numbers are big, but we're not talking massive profits, and there's a reason for that. And that's because quite often our contracts are, yes, large, but they are over an extended period, and we don't have volumes. And so all the techniques that you'd use in optimising production basically have never really factored into the way that we do things, because it's just not practical. We also have some other considerations. So I think the last time we had what you might call a decent production volume was during World War II. And we're unlikely to see those production volumes again. So where does that leave us today? Our production systems, we need to track, trace materials, part numbers, test results, who built it, the operator. So we need to track that information, but not quickly. So if you compare us to the food industry, where with fast-moving food, you need to have the traceability, that actually, infrastructure is actually quite difficult to put in place for us because we don't have those volumes. So the business case for modern processes doesn't always stack up. And I know that sounds a bit weird, that says a company that produces high-tech goods, high-tech technologies, and invests in those should be able to do things smarter. That's not to say we don't use modern methods of manufacture, we just don't have the impetus to move it along very quickly. But one of the things that's changing is the disruptor, which is actually a lack of human capital. That's the problem that we're actually facing. If you think about the $200 million that the Australian defence, Australia wants to spend in the defence arena, is my biggest worry, is not actually being able to spend that in Australia, not because we have a lack, but because we have a lack of people. And so that is now starting to put the pressure on that says, why have people doing non-value-added jobs when we could replace those with machine jobs? And let's focus on maybe getting some better value out of the people we actually do have. So the reduction of cost of the technology and the pressure of that resources is actually now starting to swing thoughts around what are those opportunities, innovations and systems that are actually in place in other markets. It's not that simple though, of course, because in defence, a lot of the equipment that we produce is classified, which is what you want when you're at war. You don't want people understanding about your products. And so the classification of some of our equipment means that transferring information about that equipment is restricted. And there's lots and lots of rules with our customer and our internal processes that govern the management of confidential, secure, classified data. We've actually had a recent example of that where we were trying to implement RFID in one of our warehouses, and that sounds so ridiculous when I say it, that's been around for so long. But one of our issues was transmitting classified data to not across our own wired network or our own intranet, is actually the printing of the label out in the warehouse. And I still can't get my mind around the fact that that was a significant challenge for our classified data, but it was, and it took us many months to actually get the approvals to use it internally as well as externally. So the numerous benefits that come from RFID that you see in other industries, we're actually struggling to implement. However, now we've done it once, we can do it again. Next on the list is the International Traffic in Arms Regulations, which is really the rules that the US employ on their defence export. And so a project like the Joint Strike Fighter, for example, which is all ITAR, not only is the data restricted, sometimes you can't even see the product, even though you could never build a Joint Strike Fighter from that product. It doesn't matter, you can't see it. And who else can see it if that person is from a country that's not a prescribed country that the US government would basically approve? And that could be even somebody who has the right to citizenship in another country. They might be Australian, they might be multi-generational Australian, but if they still have that ability to have a passport in another country, then that uncontrolled access to ITAR data is another factor. Finally is the cybersecurity robustness of our supply chain. And that comes in two forms. One, it's actually about the business itself, and you might have seen in recent press, there were a couple of small companies in Australia that were hacked, and Joint Strike Fighter data was accessed. Obviously that's a concern. but also cybersecurity in their products. We invest a lot of money in our platform design to ensure that the products that we have are also cyber secure. I think there's an example about Jeep engine management system being hacked through the radio. You can imagine what it would be like if there was a crew out at sea and their ice cream refrigerator was hacked by somebody, and you think that's not a joke. People actually get upset when they can't have their ice cream in the middle of the Mediterranean. So these are issues. So one is attacking the mission itself, but also attacking the viability of the crew is an issue there. So it's not all bad. We are challenging those constraints. The cost of the technology has come down significantly. We've got some really great proven systems that are out there that we can start to bring in, and indeed we've started that journey along the way. I'd now like to talk a little bit about our own products in terms of digitisation. We took the opportunity when we started the design of the Type 26, which is the new frigate in the UK, to work with the Ministry of Defence around developing a digital design. I think yesterday there was talk about the digital twin, and essentially we have, for the first time in a complex warship programme, produced a digital model that not only includes the drawings, but has the design data, the sustainment data, all the margins, all the decision information about why we chose a particular product, as well as the production system, the production outcomes and sustainment of the vessel, so all in one. And that is a major step away from the traditional way that ships are designed and built. And that in itself has its own challenge, which I'll come back to. So what the key thing around that's given us is that the customer and the Navy, the end users, have been involved in the decision making all the way along, and we created a visualization suite. That visualization suite is in 3D. We actually have three. We have one in Bristol, which is in the south of England, one in Portsmouth, which is in the south of England, just a bit further along the coast, and one in Glasgow in Scotland. And those engineers work together in all those three centres to basically not only do the design, work together on the design, but also get the customer involved, Lloyd's accreditation involved in those design decisions. And we're lucky enough, having won the Hunter class competition, the Future Frigate, that we will have those design centres here in Australia. We already have a small version in Canberra, which we've used to educate people in Australia around the capabilities of the ship and what that involves. But we will have others, and there's no limit really to how we can connect those up. So we could have one in Adelaide, we could have one in Melbourne, one in Sydney, and that's actually quite important if I talk about back to the human capital piece that says, well, how do you actually make the use of the resources without necessarily bringing everybody to Adelaide, which obviously is not necessarily practical. So that's quite an exciting bit of software for us. I know there's lots of VR and all that kind of stuff out there, but to have it on a complex warship design is really a step forward. The next part to that, the follow-on part, is actually when I talk about the shipyard. So there's lots of talk about a digital shipyard. What does that mean? And you'll laugh when you see the video because there's lots of dots. But at the end of the day, the digital shipyard is really about optimizing the production of ships, which is a very old-fashioned industry in some respects. And so we've got to change people's mindset. So it's not just about the facilities that are at the yard. It's not just about the way we use RFIDs in the yard or wearable technologies, how we employ different safety systems, the use of drones and things like that as part of our plan. It's actually about the people side. How do we bring a culture of people who are used to doing things in a very, in some ways, old-fashioned way into a modern yard that produces a yard that will be the envy of the world in terms of its automation, its safety, and its output. And that's really our vision for not just the ships, but actually the shipyard itself. So I think we've got a unique opportunity here in South Australia to really move an industry that's probably, whilst high-tech, has not really in high-tech production into the modern methods. And we're really excited about that. And I'd like to show a video, and I'm going to do some disclaimers on the video. One, the music's terrible. I didn't choose it. So I apologise for that in advance. Secondly, we have not demolished ASC. If you actually see, if you've been down to Techport, you will know there are other buildings on that site, apart from the ones shown on the video. And the other thing is that there's no people. That's not the case. There will be people in the yard. But apart from that, the video is great. I'm going to come back onto the panel. I'll come back on stage. So if you could play the video, hopefully what I've said will sort of come to life as a result.
was cool. That was cool. Yesterday morning, in my opening comments, I talked a bit about a vision for the future whereby we would take those enabling technologies, the building blocks of the next phase of digital innovation, and we'd begin to assemble from the ground up entirely new supply chains using automation, artificial intelligence, robotics, and digitization. And I'm very, very happy that Sharon Wilson was able to share that vision with us so that you can see that that vision of the future isn't so far off. It's actually happening right here in South Australia. Very powerful, and thank you for that. Thank you for sharing that with us. What's important to note is that these systems are not necessarily replacing human workers, they're augmenting human workers. They're making them more capable, and in some ways, they're upskilling the workforce. Now, the second big building block that I mentioned, and that other speakers referred to yesterday, was automation, software automation, robotics, and in particular, artificial intelligence. And we thought it'd be useful to find someone who's local, who could comment on those technologies and tell us a little bit about the state of the art here in South Australia. And that's why we're so gratified that our next speaker will be able to share with us a good understanding of the state of artificial intelligence and machine learning in South Australia. He is the founding director of the Australian Institute of Machine Learning and a chief investigator for the Australian Centre of Excellence in Robotic Vision, and a professor of computer science at the University of Adelaide, and the author of more than 300 papers. Our next speaker is Anton van den Hengel. Please welcome him to the stage.
Hello. Fantastic. And you can hear me as well. I'm sorry I don't have a soundtrack to match BAE's. That was quite stirring and moving, and all I have is me. So yeah, I'm Anton van den Hengel. I'm the director of the Australian Institute for Machine Learning. We are about 110 people these days in the University of Adelaide. And we're working in machine learning, largely computer vision. Computer vision is the process of trying to make computers see a little bit like humans do. And I'm about to tell you what machine learning is more about. We work with Google and Facebook and develop technology for local SMEs, and I don't know, just did a medical device that got FDA approval, and we were first in visual question answering, which is a really AI bit of the machine learning spectrum. Recently delivered technology to Bayer. There's 1,000 things going on. Maybe the scariest one is that we published a result recently that we can tell whether you're going to be alive in 5 years' time straight out of a chest CT scan. So you go and have your scan taken, and it'll tell you, you've got a 70% chance of still being alive in 5 years' time. And it's quite good, right? It's quite surprisingly accurate. So part of the reason I'm here is to tell you what machine learning is. Actually, the majority of the reason I'm here is to tell you what machine learning is. Some of you will no doubt know what machine learning is already. Somehow my slides advanced ahead of me, but I guess that doesn't matter. When you try to tell a computer to do something, so your car has between 1 and 20 computers in it, depending on how old it is, and you've got at least one in your phone and one on your wrist, and you're sitting behind one typing something. All of those computers are pretty much programmed like this. So if you want to tell a computer how to do something, then you write code. And there's a few subtleties to the process of writing code. It's an incredible skill. People practice a long time to get good at it. But really, it means that some human has to understand the process. So if you want a vending machine, then a human has to figure out what this vending machine's going to do and write out all the rules and come up with a set of steps that this computer should go through in order to implement the function of being a vending machine. There are, however, all of these things that both that we can do and that we'd like to do that we can't describe and that we can't write that kind of algorithm for, right? So this here is an algorithm, but which is a recipe, right? So it's a recipe for how you do something specific. So it could be the recipe for how you be a vending machine. There are all of these things that we don't have algorithms for, we don't have recipes for, including running, catching, throwing, recognizing your parents, remembering what you had for lunch. There's all of this stuff that you can't explain how you do. And then there's all the other stuff that we can't explain, that we can't do, but that we'd like to be able to do. So if you want to teach a computer, so one of the classics was distinguishing images of cats from images of dogs. And it's not a particularly practically important function. Distinguishing images of cats from images of dogs isn't something that people have wanted to do for the last 100 years. In fact, there's a real problem in machine learning in general that most of the things that we do seem really simple to humans. But if you want a computer program that can distinguish images of cats from images of dogs, then you could have a crack at it, right? You could try to write an algorithm. You could try to write the recipe for how you could do it. Unfortunately, they're both vaguely brown and furry and have black noses and forelegs and tails, and there's as much differentiation in the class dog, from Great Danes to those bald Chihuahua-looking things, as there is between dogs and cats. So, dogs and whales is a bit easier, right? You just write something that's kind of a blue detector and you'll get away with it. But dogs and cats, there's no easy distinction that you could come up with. There's no human devised recipe, not least because we don't understand how we do it, right? You will recognize the distinction between an image of a cat and an image of a dog subconsciously. You can't even turn it off. Right? If I show you an image of a cat or an image of a dog, it's instant. It's in your head, right? Nonetheless, if I introduce you to someone who's never seen a cat or a dog, no amount of conversation, no amount of explaining how you think you do it is going to tell them how to achieve that, right? So you don't know how you do it. Well, I don't know how I do it anyway. So machine learning, in contrast, is the idea that the machine learns to do it by itself. So you show it a whole lot of examples of, in this case, images of cats and images of dogs, and it finds the distinction between them by itself. If you write a program, if the best expert we could find tries to write a program to distinguish images of cats from images of dogs, the program will be about 70% correct, something between 60 and maybe 75 if somebody really nails it. Humans are about 95, 96% accurate. The alternative to the human writing the algorithm, though, is this machine learning process where you just show it a whole lot of examples and it's 98% accurate. Right? So it is capable of learning things that we can't tell it how to learn. And that's the whole idea between machine learning, right? Now that I've given you such an amazing explanation of it, you're all right on top of it, right? That's what machine learning does. An image is a really complicated form of information. Again, there's this problem working in machine learning that humans do all this stuff automatically. You can't help but see that as a cat, right? Despite the fact that you've never seen that cat before. You've never seen a cat do exactly that before. You've never seen that image of that cat before. Nonetheless, at least 95% of you identified that as cat instantly, right? Subconsciously, without thinking about it. Actually, that's not, all that is an array of numbers, right? Every one of the little squares that image is made up from is just 3 numbers that give you the color of all those squares. That's just an enormous matrix of numbers. Cat is in your head, right? That's, it was produced by applying a camera to the process of taking a cat, but actually all the catness left when the cat went, right? All there is an array of numbers. And you've got to try to turn that into an image, right? Images are, this are a really complex form of information. In old TVs where you used to get snow on them when you were tuned to the wrong channel, that TV was randomly generating images for you all of the time that you watch that snow. And it doesn't matter how long you watch it, it's never going to generate an image of a cat, let alone that image of a cat, right? That is an incredibly unlikely arrangement of numbers. Yeah, it's the odds of that arrangement of numbers, it's 1 in a number that's more than the number of electrons in the universe, right? It's incredibly unlikely. And nonetheless, you've instantly turned it into a cat. So that's the capability we're trying to mimic. And actually, the way that, we spend a lot of time. We do a lot of maths, and there's fantastic maths in machine learning. It's a wonderful opportunity. Well, this has developed a mind of its own. There's a fantastic opportunity in machine learning to do maths, but this algorithm here is incredibly simple, and you can use it as a way of thinking about absolutely every machine learning algorithm, right? Once you understand this unbelievably simple algorithm, you'll be able to apply that. Every time somebody tells you, machine learning does this amazing thing, you'll be able to think, well, I could probably do that with Anton's really simple algorithm, right? So this algorithm is called nearest neighbor, and it's that simple. So we have a database. So this problem is trying to recognize handwritten characters, handwritten digits. The problem came from the US Postal Service because they wanted to recognize automatically postcodes written in those little squares in envelopes, right? So these are numbers from little squares in envelopes. It's a database of 60,000 of those little squares, and there's 6,000 examples of each of the digits from 0 to 9. And as you can see, there's a really small subset. There's a crazy number of ways that people represent the number 2. Yeah, there's loops and there's squishes, and my handwriting's terrible, so mine's probably not in there, but there's at least 2 ways that people write 4. You've got to have an example of every slant, every size, some people put bars on 7s. You have to have it all in there. Then you get your query image, right? So again, I can't show you that query over there without you instantly turning it into a 4. But actually, it's just a bunch of white blobs on black blobs, right? On a black background. It's a pattern of blobs. It's not a 4, right? The question is, how are we going to turn it into a 4? And the nearest neighbor algorithm just says that you go through your data set and you search for the closest digit, right? And closest could be something as simple as just the most overlap, right? Each one of these is I actually can't remember if it's 10 by 10 or 16 by 16, but something like that. You just take your query set of blobs and you push it over all 60,000 of these examples that you've got. You find the one that's got the most white in common, and the digit that one is the digit that you're going to pick. And hopefully it will, the nearest neighbor will be 4. We already know that thing up there is a 4, and so the answer is a 4, right? So that's machine learning, yeah? We showed it a whole lot of examples of something, and then we gave it a new example that it hadn't seen before, and it can give you back an answer that's right most of the time. And nearest neighbor is an incredibly powerful algorithm. It performs almost as well as most things. A lot of machine learning is really just trying to reduce the amount of data you need to be able to make this thing work. So digits drawn in little boxes is a relatively constrained kind of a problem, right? You have to draw the digits in the box. They're only 0 to 9. Digits are devised by human beings to be recognizable, right? It's kind of the point of them. It's a relatively constrained sort of a problem. Nonetheless, you have to have 60,000 images to be able to capture the digits from 0 to 9. That seems like a lot of digits, right? A lot of examples. But it doesn't, like if you go in there with 10,000 examples, it doesn't work. There's just too much variety. So, you know, the big question with machine learning is always, how much data do I need? And the answer is always more. But this is why, right? So one of the many reasons that I tell people about this nearest neighbor thing is because it gives you a handle on how much data you need. If you want to recognize zeros, then you have to give this algorithm enough examples of zeros that every time you get another zero, the closest thing in your database is going to be a 0. Not some funny 8 or somebody who's written a 2 a strange way or whatever, right? It has to be 0. And, you know, 7s get close to 1s pretty quickly, and 3s and 5s overlap. You know, there's all sorts of things. So you have to have a lot of examples. The data you're going to use has to encapsulate all of the variation, right? If you want to recognize cats, you've got to have examples of every cat from the biggest one to the smallest one, and they've got to be in every pose that a cat can make, and they've got to be taken from every camera angle that you're going to see and in every lighting condition that you're going to see, right? You have to enumerate all of those combinations in order to make sure that the closest image you get is going to be is going to have a cat in it. All right. So that might give you some idea about where machine learning sits in relation to artificial intelligence. And people use AI to mean machine learning these days, which confuses things. But true AI, real AI was about trying to come up with something intelligent. And given that intelligence is undefined and artificial doubly so, I can't really give you anything that's a whole lot tighter than just this kind of hand-waving idea that you might recognize an intelligent machine when you see it. But I reckon that checkers or drafts, right, wasn't as difficult as we thought it was. There's a whole lot of problems out there. So chess, even Go, really. And a bunch of these things got solved in the name of artificial intelligence that really didn't really require all that much intelligence. So, winning at chess actually only really requires a big enough computer. Unpacking the dishwasher, that takes intelligence, right? You're going to be unpacking your own dishwasher for a long time to come yet. The robot revolution is at least 3 times as far as you've been told, not least because you're going to be unpacking your own dishwasher, hanging out your own underwear, and digging your own holes in the garden for a very long time yet. Okay, and deep learning is the revolution. If you look at driverless cars and all of these things that do amazing stuff with health records, deep learning is an algorithm within machine learning that has been achieving amazing things. And deep learning is the reason that we can recognize images of cats from images of dogs at 98% when humans are only about 95 or 96. It just works better, right? Deep learning is how Facebook recognize you in your pictures and all of your friends. Deep learning is how Facebook recognize what scene you're in. Facebook draw different conclusions about people in the same image in an office environment to a beach environment. It's done with that. The driverless cars use deep learning to recognize what's road and what's car and what's toddler. Deep learning has caused a revolution in machine learning, largely because it works. So I better talk more quickly. Some stuff that machine learning isn't. There's a whole lot of people worried at the moment about where their data's going. I personally think that it's overrated as a concern, and that actually the majority of the population are giving their data to Facebook for nothing. And so they don't seem to be too worried about it. Cybersecurity is a real issue, but it's not machine learning, right? You have to protect data when you capture it, whether or not you use it for machine learning. If you capture it and it gets stolen without you extracting any value from it, then you've taken all of the risk and none of the reward. If you're going to take the risk, at least take the reward and do something with the data. Data can escape from a filing cabinet. It doesn't need to be processed by machine learning for it to get out. Machine learning isn't watching you. Machine learning doesn't care. It has no capacity to care. It doesn't know who you are. It's not interested in your shoe size. And just because it's not interested in anything, right? It's just, machine learning is matching your, with some bit of information against a whole lot of other information. The question is whether humans want to use it for something else, right? The machine learning itself is completely incapable of caring about you. It's incapable of caring about anything. And particularly, it's not racist. There was a whole lot of stuff out of Microsoft's, was a few things, right? Where Microsoft had a bad run. They had one where they turned images into captions, and that hadn't been trained on African Americans, so when they showed an African American face, it said gorilla or monkey, something like that. That bit of machine learning has two labels. One is 110111111111, and the other is 010011100111, right? And it applied the second one when it should have applied the first one. If you think that the second one is racist, then it's in your head, right? That doesn't mean that the outcome's not racist. I'm not downplaying it. It's just that the machine that did it isn't racist, right? You can complain about the people who gave it the training data. You can complain about the question that the thing was asked to solve. You can complain about how the outputs are measured, but the machine itself is incapable of racism. And, the risks have been greatly overstated. I would love to tell you, my slides are going by themselves. I would love to be able to tell you that, that the Terminator's around the corner, right? That we are going to hit the singularity, that that you're going to have the Terminator can unpack your dishwasher, right? But unfortunately, we're as far from that as we've ever been. The truth about artificial intelligence, real artificial intelligence, is that there's been very little progress made on true artificial intelligence over the last 20 years, where, machine learning's come a long way, but AI, not really. So there's this big question of interpretation, right? There's all of this fear going around. There's this great story from the US, and I should say before I tell it to you that it's probably apocryphal. It's a bit hard to figure out whether it's actually true. But the story is that a father of a 16-year-old girl in the US went to Target and banged his fist and said, "You're sending my daughter maternity products, you're kind of normalizing teenage pregnancy, how dare you," all of that sort of stuff. He went home and she said, "Well, actually, Dad, I'm pregnant." And he goes back and apologizes. Target are horrified, but the reality of it is that the machine doesn't care about pregnancy. All the machine is doing is saying, well, people who bought strawberry lollipops, 3 pieces of cheese and rubber bands, in 3 months' time came back and bought something that's associated with maternity, right? They bought, formula or, whatever. It doesn't care, right? It's not drawing any conclusion. If he drew a conclusion, he was horrified. It's not horrified. It doesn't care, right? And this is the same process over and over again. People read a whole lot of stuff into this, assume that the machine is capable of much more than it is, because, the machine's just not up to it, right? The machine is not capable of drawing the kind of conclusions that would take. The machine learning in that instance is just trying to figure out how to sell you more infant formula, right? They don't care. All they want to do is sell you stuff, right? They're just trying to predict what you're going to buy. All right, and the other thing that's going on is that there's all this fear about they're going to steal our children's passwords. The truth is that it's here now, right? Machine learning, quantum computing has had a lot of investment. It stands to be fantastic technology. It will have a disruptive impact in a very specific technological area, maybe sometime in the future, right? Machine learning is having a disruptive impact across the entirety of the economy and most of society, and it's happening right now. It's just that people don't seem to see it. Facebook is a machine learning company, right? Whatever else you think they do, they're a machine learning company, right? Machine learning decides which of the effectively infinite number of posts it could show you that it's going to show you, right? It learns from what you actually watch to see what you want to watch, right? It learns how to sell you stuff. It learns how to predict from your statistics, including what you actually watch, what they can actually sell you, right? They've got hundreds of thousands, millions of ads they could show you, and what they're trying to do is show you the ad that you'll actually click on, right? That's a machine learning problem. The way those problems used to be solved, right? The way that you used to do ad targeting is either to put an ad on TV and show it to everybody, just in hope that it'd have some impact, or you'd have a human expert try to learn that mapping from kind of whatever statistics, these kind of statistics, to the stuff that people would buy. Machine learning is just better at it, right? Machine learning can take 1 million measurements about you and predict what ad you'll actually click on much better than a human can, right? And that's the process that's going on. That machine learning is replacing expertise, right? Because it's better. It's better than a whole lot of things that farmers do. It makes them more efficient, right? It's better than a whole lot of things that radiologists do, and it makes them more efficient. It doesn't replace farmers or radiologists. You still need farmers and you still need radiologists. You just make them better, right? You make them more effective. And it's doing amazing things. You can take a picture of somebody's retina with a phone, right? You have to have a little lens on the end of your phone and a light. You can take a picture of somebody's retina and see if they've got heart disease, diabetes, all sorts of crazy things, because it's written in your retina. That's a real technology that's out there and happening now. And the relationship between what your retina looks like and what disease you've got is pretty complicated. It's a fantastic opportunity in general. It's revolutionizing most industries. Right? It is changing the way we live right now. Uber are a data company. Right? If you ask Uber what they don't do transport. They're a data company. Google are a data company. The reason it's going to be very hard to replace Google, we had a whole, back when the internet was young, we had all of these search engines, and they all just kind of got replaced by Google. Google hasn't been replaced over the last decade because they've got your data. It's going to be very hard to replace them because they've got such a lead on it already. It's changing agriculture. It's changed transport. It's changing everything. It is increasing productivity, and whether you like it or not, productivity growth, as far as I'm concerned, is essential to maintain our standard of life. I don't think that's a particularly positive thing, but I still think it's true. It will let your GP scan you while you're standing there, right? So at the moment, you go to your GP and they want to know, they want an ultrasound done, right? In the future, they will just hold their phone at you, and it will carry out the ultrasound, and it will, they'll get the answer right there. You won't have to go off, book an appointment, go to somebody else, pay a whole lot of money, get the information sent back, and all that. Tricorder, right? They just go in and find out what's wrong with you. It will drive you to work, or at least fly you to work. I must admit, I'm a bit skeptical that we're going to have completely driverless cars anytime in the very near future. But Uber at least are planning to fly people to work in Dubai in 2020 in quadcopters, right? You just go and get into a quadcopter and it'll fly you there. It's actually a lot easier as a process than trying to drive with a whole lot of humans out there. And maybe it'll even generate TV that you actually want to watch, right? At the moment, it's already, you know, the Netflix challenge was about finding stuff that you actually want to watch on the basis of what you've watched in the past, what you liked in the past. The next step is to generate stuff on the fly that you actually want to watch. And it's kind of, you know, it's coming anyway, right? The question for Australia, but particularly for Adelaide, is how we're going to react to this. You know, Facebook already have your data. Google have your data. There's no point legislating to try to save your data because it's already gone. Right? The question, you know, these technologies are coming in from overseas and they will continue to come in from overseas. The question is whether we're going to participate in this new economy. It will change the economy. Adelaide's in a fantastic position. We have great data. And data is really the distinguishing factor in so many of these applications. We've got great internet, we've got a fantastic quality of life. That's the big one, right? People who work in these companies make a lot of money and they're looking for somewhere to live that doesn't suck. And a whole lot of the places that they are asked to live do, and Adelaide doesn't. That's a huge advantage that we have, right? We also have great technology. You know, we have a history in this country in general, but in Adelaide specifically, of developing fantastic technology. And as I said before, the change is coming anyway, right? We are, our geographic isolation kind of helped us for a while there in isolating us from the rest of the world. This technology does not obey borders. You're already on Facebook, which means your data's in the US. Local data legislation isn't going to make the difference. And we need to, the big challenge, the huge challenge that I hope we can get on top of is that we need to create an environment where we are enthusiastic about experimenting in this environment, right? We need to create a culture of experimenting with data, not this culture of fear, right? We need, the data is where the value is. And if we don't leap upon the data that we have and extract as much value out of that as possible, in order to get the first mover advantage in these new industries, then we will just wind up importing other people's technology. We'll be a place where people come to dig stuff up. The major challenge for that, as far as I'm concerned, is this kind of environment of fear that we seem to be developing rather than enthusiasm. It will mean that there is a greater risk that somebody will hack in and steal your shoe size, right? But out of it, we stand to gain an economy that is, that will ride the tsunami of this economic change that's ahead of us. All right, and that's just some stuff about us. We're about to move into the Lot 14 site in the corner of Frome Road and North Terrace, into that big building right on the corner there. We're looking to work with interested South Australian, well actually international companies. We're working with people all over the world. We're trying to form an ecosystem of high-tech development around that site and around the Institute particularly. And yeah, we're getting quite good at working with companies in adding value. I think that's enough. All right. 2 minutes late. That wasn't bad, eh?
That was very nice. Thank you. That was very nice. I asked Anton if he could demystify artificial intelligence and machine learning, and I think he did a very, very good job. Thank you for that. The first hype-free presentation on the topic of machine learning that I've ever heard. I guess what we just learned is machine learning depends on very simple algorithms, and it can't quite do things that are easy for human beings.
Bye.